in a chemical reaction. When we know the quantity of one substance in a reaction, we are able to calculate the quantity of any other substance consumed or produced in the reaction. The key concepts: grams, molar mass, mole, formula coefficient, liters, 22.4 liters per mole, and molecules or atoms, Avogadro's number. When we have a reaction, first of all, I need to balance the equation. In this case, I have two nitrogens, and in the right side, just one, so I have to balance the equation. There is a 2 over here, and now I have 3 times 2, 6 hydrogens. I need a 3, and this balance. Okay, then identify the data and the question. How many moles of ammonia? How many moles? When 0.6 mole of nitrogen, 0.6 mole of nitrogen react with hydrogen in excess. I don't have any data about hydrogen, so we don't need to use hydrogen for any calculation. Okay, my two data are in moles, so I have to use the coefficient of the formulas. In this case, nitrogen has a coefficient 1. There is a 1 mole. Remember, the coefficient of the formula means the number of atoms that are reacting. For ammonia are 2 moles. And we have to do a cross multiplication like this. And there are 0.6 moles times 2 divided by 1, and the result is 1.2 moles of ammonia. And that's it. Next example. First, check the equation is balanced. There's not. 1 hydrogen, 1 chloride. In the right side, 2 of each, so I have to write a 2 over here. That is balanced. Now, how many grams of copper, are need to react with 35 grams of hydrochloric acid? In this case, I need grams, so I need molar mass in order to complete my cross multiplication. Copper is a pure substance. We need to use its atomic mass. There is 62 grams. And for hydrochloric acid, let's calculate it over here. There is 1 atom of each one times 1 times 35. 35 plus 1 is 36. But I have this coefficient too. Molar mass is grams per mole, but I have 2 moles of hydrochloric acid in the main reaction, so I have to multiply this by 2, and now we have 72 grams. Cross multiplication like this. There is 35 times 64 divided by 72. There are 31.11 grams of copper. Next. In this case, equation is balanced. 1 magnesium, 1 plus 1, 2 oxygens. There are 2 oxygens and 2 hydrogens. Okay, now they ask if 3 moles of magnesium oxide, 3 mole, reacts with water. I don't have data about water, so how many grams of magnesium hydroxide are produced? How many grams? Okay, for magnesium oxide I have moles, so I need to use the coefficient of the formula. In this case is 1 mole. Magnesium hydroxide, they asked me for grams, so I need molar mass. Let's calculate it. Magnesium, hydrogen, and oxygen. 1, 2, 2. Magnesium is 24. Hydrogen 1 times 2, 2. Oxygen 16 times 2, 32. 8, 58 grams per mole. So there are 58 grams per mole. Then I mark my cross multiplication. This by this. There are 3 times 58 divided by 1. And my result is 174 grams of magnesium hydroxide. Okay, the last step. How many liters of hydrosulfuric acid? How many liters? Hydrosulfuric acid are produced if 165 grams of hydrochloric acid reacts with potassium sulfide. Let's balance the equation. I have 2 potassiums. I'm going to write 2 over here. Now I have 2 chlorides. I have to write a 2 over here. 2 hydrogens, 1 sulfur. That's okay. Now, for hydrochloric acid, my data is in grams, so I need molar mass. For hydrosulfuric acid, ask me for liters. The constant of liter is 22.4 liters per mole. There's only 1 mole because I don't have any number as coefficient. Okay, molar mass of hydrochloric acid, we calculated in 2 problems last. Molar mass of hydrochloric acid is 35. Molar mass, no, 36. But I have a 2 moles. There are then 72 grams. So I write 72 grams. Okay, cross multiplication. And 165 times 22.4 divided by 72. It is 51.3 liters of hydrosulfuric acid. And that's it.